What's going on, guys? Today we're going to be covering atomic mass. It's a follow-up to one of the videos that we already made on subatomic particles, right? So if you haven't seen that video already, I highly recommend checking out. It is going to be in the link down below. So this is a quick review from last week's video, right, where we covered subatomic particles, protons, neutrons, and electrons. Now in today's video, we're going to be talking about the masses of these particles, right? So the proton weighs 1 AMU, the neutron weighs 1 AMU, the electron weighs 0.00548 AMU. What does that kind of mean, right? So now we're going into this next part here. How massive are these particles? And this is kind of all centered around the AMU, right? So normally when we think about units for measuring masses, right, we're going to think about things like the kilogram, the gram, the pound, right? But in fields of science, we're going to standardize and use the metric system. So we're going to be using kilograms, grams, milligrams, things of these nature, right? But for subatomic particles, so anything on this list here, we're going to be using the AMU, right? And that unit itself is not really tangible. You don't really think of something in your daily life as weighing an AMU, right? And that's because of how tiny it is, right? 1.6 times 10 to the negative 24th grams is incredibly small, right? If we try to write this out on this page, this would be going all the way off to the right. So what is a 1 AMU? To simply define it, right, you can think about it as just the mass of one proton and the mass of one neutron, right? So an AMU, you can kind of use that as a reference frame. Oh, 1 AMU equals the mass of one proton, the mass of one neutron. We'll go into at the end how this was actually determined as 1.6 times 10 to the negative 24th grams, right? But what I think is important to know is 1 AMU equals the mass of one proton or one neutron, right? So now when we're calculating atomic mass, right, which is the mass of an entire atom, we're going to be adding up the masses of the protons and the neutrons within that atom, right? So within the nucleus. And you might be asking, well, what about the electrons? And that's a good question. But the electrons, because their mass is so small, right? We looked at that list where it compared the masses. We saw that the mass of the electron was incredibly small. So we're not going to actually count electrons in this calculation, just to simplify them, right? Because the mass of the electrons doesn't really give much value to these equations here, right? So the atomic mass, right, is going to be equal to the mass of the protons plus the mass of the neutrons. So all you have to do is add up, right, the number of protons and neutrons in your nucleus, and that'll give you the atomic mass, right? So if we do a quick atomic mass practice problem, and you can read this, pause it, and try it yourself. I'm just going to go right into the answer. But what is the mass in AMU of a carbon-12 atom that has 6 protons and 6 neutrons in the nucleus, right? So we can use that formula on the previous slide that had the atomic mass equal to the mass of the protons in AMU plus the mass of the neutrons in AMU, right? So it has on us for here, right, we have 6 protons and 6 neutrons in the nucleus. So the atomic mass will be equal to 6 plus 6, which will be equal to 12 AMU, right? And kind of to wrap up today's video, we're going to go back to how massive are these particles and kind of the experiment that was used to determine the mass of an AMU, right? So essentially, 1 AMU is also defined as 1/12 of the mass of carbon-12 atom, right? So they were able to get the mass of a carbon-12 atom experimentally and divide that by 12. And the reason why they divided it by 12 is because there were 6 neutrons and 6 protons, right? 12 divided by 12 is going to give you the mass of 1 neutron or 1 proton, right? Because they weigh the same, which is equal to 1 AMU. That's it for today. Thanks so much for watching, and I'll see you in the next video.